This is Gurmeet, and I'm here to represent my team AP008 in the Innovate FPGA 2019 edition. And our project is driver's drowsiness detection and the alert system. We have named it as the DDA. So basically, DDA is a standalone device which can be easily installed in the cars, and this device consists of the USB based IR camera and the DE Nano kit. So the camera is installed on the dashboard of the car in such a way that it can constantly see the driver's face, and the video from the camera is processed with the help of the Cyclone 5 SoC on the DE Nano kit. Thank you. So now I am going to demonstrate our project. This is the D10 Nano kit from the Terrasic that has got the Cyclone 5 SoC on it, and this is the IR camera that is interfaced to the D10 Nano kit using the USB OTG cable, and this is the Ethernet cable that is basically used to connect the D10 Nano kit to the home network, and this is the USB to serial cable that is used to connect the D10 Nano kit to the development PC. Actually, this is the development environment, not the final application that will be installed on the car. So in the final application, the power will be supplied by the battery, and this IR camera will be installed on the dashboard of the car, which will constantly facing the driver's face. So the idea of connecting the D10 Nano kit to the Ethernet cable is that the Linux running on the top of the Cyclone 5 will be running the VNC server, and the desktop PC will be having the VNC client running on it. So in the build environment, we basically want to analyze the video frames from the camera, and in the actual application, this will be a complete headless system where there will not be any Ethernet cable or USB debug print cable. So to get the Linux debug prints, you have to configure the serial terminal on the development PC. So after providing the power cycle to the board, it will boot the Linux. So now the Linux has been booted, and you can launch the VNC server on the Linux. So I have installed the tight VNC server on the Linux running on the top of Cyclone 5 SoC. So that I'm going to start now. It has started the VNC server on the Linux, and you can also see the IP address assigned to the board from your router's configuration. Okay, In my case, I have added the static IP to the board. So this is 192.168.1.70. So you can use this IP address to connect to the VNC server running on the Cyclone 5 SoC. So in my case, I have already added this server to my VNC client. So I am opening it now. Type the password for the VNC server. To launch the terminal, you have to select it from the start menu. Okay, so here is the DD application. In the final application, actually this will be a complete headless system, so all the things will be done by the startup script. So to demonstrate it better and for the development purpose, we use the desktop based environment. So I'm launching the driver Drowsiness alert system. As you can see, the camera has started capturing the frames, and the DDA application has started processing the frames and started detecting the eyes and face landmarks. So you can see that right now eyes are open and head is a little bit tilted. So this is particularly useful when the driver is looking outside the car. So the system is able to detect the open eyes and closed eyes when the face is not directly facing the camera. I mean, looking driver is looking outside the car. So now I am going to close my eyes so that the system will be able to detect the sleeping driver. And the system is also able to detect the eyes if you are wearing the glasses. And the head tilt scenario when you are wearing the glasses. So for the case when the interior of the car is not having the sufficient light, we have used the IR camera. So I have turned off the light, and you can see that it is still detecting my eyes open, and if I close the eyes it will detect that I am sleeping.
So now I'm opening the eyes again.